Jupiter and Saturn, the giants of our solar system, are home to a fascinating array of moons that captivate the imagination of scientists and space enthusiasts alike. Jupiter, with its immense size and powerful magnetic field, boasts a total of 79 known moons, making it a veritable mini-solar system in its own right. Saturn, known for its stunning rings, has at least 82 moons, each with its own unique characteristics. These moons come in all shapes and sizes, from tiny, irregular rocks to large icy worlds. Jupiter's moons are a diverse bunch, but one of the most intriguing is Io. This volcanic moon is the most geologically active body in the solar system, with over 400 active volcanoes spewing sulfur and lava into space. Europa, another of Jupiter's moons, is covered in a thick layer of ice that scientists believe hides a subsurface ocean, raising the tantalizing possibility of life beyond Earth. Ganymede and Callisto, the largest moons of Jupiter, are icy worlds with ancient surfaces that provide clues to the history of the solar system. Saturn's moon Titan is a world unto itself, with a dense atmosphere and lakes of liquid methane and ethane on its surface. Enceladus, a small icy moon of Saturn, is home to geysers that spew water vapor and ice particles into space, hinting at a subsurface ocean that could harbor life. These strange and wondrous worlds offer a glimpse into the diversity of planetary bodies in our cosmic neighborhood, sparking curiosity and driving exploration to uncover their secrets. Jupiter, the largest planet in our solar system, is surrounded by a diverse and intriguing collection of moons that offer a glimpse into the complexity of planetary bodies. With a total of 79 known moons, Jupiter's satellites come in all shapes and sizes, ranging from tiny irregular rocks to large icy worlds. These moons can be classified into several groups based on their characteristics and orbits. The four largest moons of Jupiter, known as the Galilean moons, are Io, Europa, Ganymede, and Callisto. These moons were discovered by Galileo Galilei in 1610 and have since been the focus of intense scientific study. Io, the innermost of the Galilean moons, is a volcanic world with over 400 active volcanoes that constantly reshape its surface. The intense gravitational interactions between Io, Europa, and Ganymede cause tidal forces that generate immense heat within Io, leading to its volcanic activity. Europa, the next moon out, is covered in a smooth layer of ice that hints at a subsurface ocean beneath. Scientists believe that this ocean may harbor the conditions necessary for life, making Europa a prime target for future exploration. Ganymede, the largest moon in the solar system, is a complex world with a diverse geology that includes both ancient cratered regions and younger, grooved terrains. Callisto, the outermost of the Galilean moons, is a heavily cratered world that provides valuable insights into the history of impacts in the outer solar system. Beyond the Galilean moons, Jupiter hosts a multitude of smaller moons that exhibit a wide range of characteristics. Some of these moons, such as Amalthea and Himalaya, are irregularly shaped bodies that likely originated as captured asteroids or comets. Others, like Meis and Adrastea, are tiny moons that orbit very close to Jupiter and help shape the planet's rings. These diverse moons offer a wealth of opportunities for scientific discovery and exploration, providing valuable insights into the formation and evolution of the Jupiter system. Io, one of Jupiter's Galilean moons, is a fascinating world with a myriad of unique features that set it apart from other moons in the solar system. One of the most striking characteristics of Io is its intense volcanic activity, making it the most geologically active body in our solar system. With over 400 active volcanoes, Io's surface is constantly being reshaped by the eruption of sulfur and lava, creating a dynamic and ever-changing landscape. These volcanic eruptions can reach heights of up to 250 miles, 400 kilometers, and produce plumes that extend hundreds of miles into space. The volcanic activity on Io is driven by the intense gravitational interactions between Jupiter and its neighboring moons, particularly Europa and Ganymede, which generate immense heat within Io's interior. This heat leads to the melting of subsurface sulfur and rock, fueling the volcanic eruptions that characterize the moon. In addition to its volcanic activity, Io is also known for its colorful surface, which is marked by various hues of yellow, red, orange, and white. These colors are the result of different compounds and materials deposited on the surface by volcanic eruptions and other geological processes. Io's surface is covered in sulfur and sulfur dioxide, giving it a vibrant and otherworldly appearance. The Moon's thin atmosphere is composed primarily of sulfur dioxide and extends for hundreds of kilometers above the surface. Io's lack of water and oxygen means that life as we know it would not be able to survive on its harsh and inhospitable surface. Despite its extreme conditions, Io remains a captivating world that offers valuable insights into the geological processes at work on planetary bodies beyond Earth. Europa, one of Jupiter's Galilean moons, has long captured the imagination of scientists and space enthusiasts due to its potential for harboring life. This moon is covered in a smooth layer of ice, which hints at the presence of a subsurface ocean beneath its frozen surface. The existence of this ocean has been supported by various observations, including the detection of water vapor plumes erupting from the moon's surface. These plumes provide evidence of a vast liquid water ocean beneath Europa's icy crust, making it a prime target for astrobiological research. The presence of liquid water, essential for life as we know it, raises the tantalizing possibility that Europa may host microbial life forms in its subsurface ocean. Scientists believe that the combination of liquid water, organic molecules, and a source of energy from hydrothermal vents could create a habitable environment for potential life forms on Europa. The Moon's icy surface is crisscrossed by a network of cracks and ridges, indicating a dynamic and geologically active world. These features are thought to be the result of tectonic forces generated by the gravitational interactions between Europa, Jupiter, and the other Galilean moons. Europa's surface also displays a variety of intriguing geological formations, including chaos regions, where the icy crust has been disrupted and rearranged. These chaotic terrains may be linked to the upwelling of warmer material from the subsurface ocean, creating a complex and ever-changing landscape. The exploration of Europa has been a key focus of several space missions, including NASA's Galileo mission and the upcoming Europa Clipper mission. These missions aim to study the Moon's surface, composition, and potential habitability in greater detail, paving the way for future missions that could directly search for signs of life on Europa. The study of Europa and its potential for life represents a significant step forward in our understanding of the conditions necessary for life beyond Earth, offering a glimpse into the vast possibilities of the cosmos. Ganymede and Callisto are the largest moons of Jupiter, each with its own unique characteristics that make them fascinating worlds to study. Ganymede, the largest moon in the solar system, is a complex world with a diverse geology that sets it apart from other moons. It has a rocky core surrounded by a thick mantle of ice and a surface covered in both ancient cratered regions and younger, grooved terrains. These grooved terrains are thought to be the result of tectonic forces that have reshaped Ganymede's surface over time. The moon also has a thin atmosphere composed of oxygen, making it one of the few moons in the solar system to have a breathable atmosphere. Ganymede's magnetic field is unique among moons, indicating the presence of a subsurface ocean that may contain more water than all of Earth's oceans combined. This ocean is thought to lie beneath a layer of ice several miles thick, providing a potential habitat for life. Callisto, the outermost of the Galilean moons, is a heavily cratered world that offers valuable insights into the history of impacts in the outer solar system. Its surface is covered in impact craters of all sizes, indicating a long history of bombardment by asteroids and comets. Callisto's ancient surface has remained relatively unchanged for billions of years, making it a time capsule of the early solar system. The moon's lack of geological activity means that its surface preserves a record of the impacts that have shaped the outer solar system. Callisto's icy surface is composed of water ice and other volatile compounds, giving it a bright and reflective appearance. The exploration of Ganymede and Callisto has provided valuable insights into the diversity of planetary bodies in our solar system and the processes that have shaped them over time. These moons continue to intrigue scientists and space enthusiasts alike, offering a window into the complex and dynamic nature of our cosmic neighborhood. Saturn's largest moon, Titan, is a world like no other in our solar system. With a thick atmosphere and a diverse landscape, Titan is a fascinating destination for scientific exploration. One of the most intriguing features of Titan is its methane lakes and rivers, which cover the moon's surface and play a key role in shaping its geology. These liquid methane bodies are thought to be fed by methane rainfall, creating a hydrological cycle similar to Earth's water cycle. The presence of lakes and rivers of liquid methane on Titan's surface was first confirmed by the Cassini spacecraft, which observed dark patches that changed in size and shape over time. The largest of these lakes, such as Kraken Mare and Ligeia Mare, can span hundreds of miles and reach depths of up to 300 feet. Titan's methane lakes and rivers are not only visually stunning, but also provide valuable insights into the moon's complex climate and geology. The methane on Titan acts as a key component in the moon's atmospheric chemistry, forming clouds and contributing to the formation of organic molecules that rain down onto the surface. These organic compounds, combined with liquid methane and ethane, create a rich environment that could potentially support exotic forms of life. Titan's landscape is also marked by vast sand dunes that stretch for hundreds of miles and are sculpted by winds and geological processes. These dunes are composed of organic particles that have settled on the surface, forming intricate patterns and shapes. The study of Titan's lakes, rivers, and dunes has provided valuable insights into the moon's past climate and potential for habitability. Future missions, such as NASA's Dragonfly mission, aim to further explore Titan's surface and investigate its potential for hosting life. Titan's unique combination of methane lakes, rivers, and dunes make it a world of endless fascination and discovery. Enceladus, one of Saturn's intriguing moons, is a small icy world that has captured the attention of scientists due to its unique geysers and subsurface ocean. This moon is covered in a thick layer of ice that conceals a global ocean beneath its surface, making it a prime target for astrobiological research. Enceladus is known for its geysers, which spew water vapor and ice particles into space through long fissures known as tiger stripes near its south pole. These geysers are powered by the tidal forces exerted by Saturn, which cause the moon's icy crust to flex and crack, releasing the water from its subsurface ocean. The plumes of water vapor and ice particles ejected by Enceladus's geysers have been studied by spacecraft such as Cassini, providing valuable insights into the composition of the moon's subsurface ocean. Analysis of the plumes has revealed the presence of organic molecules, salts, and silica particles, indicating a complex and dynamic subsurface environment. The discovery of these geysers has raised the possibility that Enceladus may harbor the conditions necessary for life beneath its icy exterior. The subsurface ocean of Enceladus is thought to be in contact with a rocky core, providing a potential source of energy and nutrients that could support microbial life. Future missions, such as NASA's planned Enceladus Life Finder mission, aim to further explore this intriguing moon and search for signs of life in its subsurface ocean. Enceladus's geysers and subsurface ocean make it a captivating world that offers valuable insights into the potential for life beyond Earth. The exploration of the moons of Jupiter and Saturn has provided us with a wealth of knowledge about the diversity and complexity of planetary bodies in our solar system. From the volcanic activity of Io to the potential for life on Europa and the methane lakes of Titan, each moon offers a unique window into the mysteries of the cosmos. The discovery of geysers on Enceladus and the subsurface ocean of Ganymede have opened up new possibilities for astrobiological research and the search for life beyond Earth. Future missions, such as NASA's Europa Clipper and Dragonfly missions, aim to further explore these fascinating worlds and uncover their secrets. The implications of these discoveries extend far beyond our own solar system, providing valuable insights into the potential for habitable environments on other moons and planets in the universe. The exploration of these strange worlds challenges our understanding of planetary processes and fuels our curiosity about the vast possibilities of space exploration.